Hi everybody, this is Damien Brady. I'm a solution architect with SSW, and I'm joined today on SSW TV by Troy Hunt, who's a developer security MVP based in Sydney. Hi Troy, and thanks for coming.
G'day Damien, thanks for having me on.
No problem. So I just wanted to start with a blog post that you recently published called Hack Yourself First, which is an intriguing title. I was wondering if you could tell us a little bit about that.
Yeah, sure. So look, the concept of hack yourself first, and I guess first of all, to give a little bit of credit, the term came from a guy called Jeremiah Grossman who heads up White Hat Security, and he did a talk on TEDx a little while ago, TEDx Maui, called Hack Yourself First. And the point that Jeremiah was trying to make is that we as developers need to be able to learn how to go on the offense, the cyber offense he called it, just to put that C word out there, go on the cyber offense to try and find risks in our own applications before online attackers do. And I really like this premise. It sort of resonated a lot with me because it's a very sort of empowering idea to be able to go out there as a developer and actually understand what to look for, understand the sorts of vulnerabilities that an attacker might try to find. So I wanted to write this post, you know, in part to sort of make that point, but in part to say, hey, there's a bunch of stuff out there that using nothing more than your browser you can easily see. And you know, a lot of people will call these out from time to time. Sometimes they'll say, hey Troy, you know, this guy over here, look what he's doing. And there's just such readily observable sorts of risks. And I wanted to use that post to, you know, point a bunch of them out.
Okay, so it's really about taking the offensive, taking the front foot, I suppose, as opposed to waiting until somebody hacks you.
Yeah, it's about being very proactive. And of course, there's a lot of other risks that are sort of further behind the scenes that you might need to drop back to the code to sort of fully understand. But these are the ones that are sort of really clear and present right in front of you.
Okay. So what are the main ones? So as developers, you know, we think a little bit about security because it's part of the job. But a lot of the time we'll do, you know, a file new project and flick the switch that says we're using a forms MVC application, and that's about as far as we go. So what are the big things? What are the gaps that most developers are missing?
Well, look, I mean, probably one of the easiest ways to kind of point out the big obvious ones is there's a very good publication from OWASP, the Open Web Application Security Project. So they have this publication called the Top 10, and it's the top 10 web application security risks. And the first ones that stand out, and people will probably be familiar with the term, so number one is injection, which we normally think of as SQL injection. So if you are going to take untrusted data, so data that might come in via the form or the query string or even a request header, how are you making sure that that data can't actually have malicious content in it, which when sent to SQL Server actually breaks out of a query context and or rather breaks out of the data context and actually starts to manipulate the query. So SQL injection is a big one, and certainly we can build insecure applications in ASP.NET for SQL injection. The second one is cross-site scripting. So, you know, how do we make sure that an attacker can't pass a query string to a request which siphons off the cookies from the page, for example? And it goes through a whole bunch of things like that. And we have some degree of native defenses for these risks, but it's still very easy to build applications that are vulnerable to them.
Yeah, definitely. Just on that cross-site scripting, I know, and this is sometimes an issue with web forms in ASP.NET. You'll get the prevention of, you know, script tags and tags being sent through form fields. Is that the kind of thing that we kind of get out of the box that makes us feel a bit safer, I suppose?
Yeah, so we get request validation out of the box. So if you go to an ASP.NET application and you put a script tag in a form field or in a query string, you'll get the native request validation, which will throw up its hands and say, you know, this is a potentially malicious request, I'm not going to process it. And it's kind of good and bad. It's good because you get some form of native defense without trying. It's bad because a lot of the time people turn it off because it gets in the way. So .NET Nuke, for example, you can't create a new .NET Nuke application without having request validation disabled completely across the entire site because it has this CMS component where you've got to be able to drop back to an HTML editor, and that HTML editor needs to be able to send HTML tags. So they've got a legitimate use case, but unfortunately they've had to just turn it off across the board so you don't get that protection anyway. And they have actually had incidents. There's certainly been versions of .NET that have been vulnerable in, say, the search feature. So, you know, you search for a term and then it says you search for blah, and, you know, that didn't get native request validation, and they didn't implement the right controls to make sure that if someone did try to put XSS through there, it didn't actually get through and cause damage.
Yep. Okay. So that's an example of something that a lot of developers are aware of. Don't just blindly trust the data that's coming back. Is there anything that is particularly malicious, I guess, that a lot of developers completely overlook or aren't aware of?
Look, I think there's a couple of different areas, and how malicious of it or how malicious it could be really sort of depends on what we're protecting. But the two things that I find are probably most frequently not well understood is the storage of passwords, so if the right hashing process is being used, and also the implementation of HTTPS. So I see a lot of different misinterpretations and misunderstanding about what HTTPS is and what the right way of using it is.
Okay, so can we drill into that a little bit more? You mentioned cryptographic storage of passwords. I think a lot of developers would assume, you hash the passwords and you use a salt and store it in your database, and that's all fine. Is that enough?
It depends how it's done. So a lot of developers understand what hashing is and that hashing is important, and a lot of them don't even get that. In fact, one thing a lot of people don't get, and I was talking to someone about this just today, is that there's a fundamental difference between hashing and encryption. So they are both means of cryptography, but they're very, very different. So when we think about password storage, we've really got three different options. So we've got plain text, so you have no protection whatsoever. And incidentally, ASP.NET has modes for all of these three storage mechanisms too. You've got encryption, which ultimately is symmetric encryption. So it's the same key to encrypt, decrypt, and the data is stored with the cryptographic process, but it can be decrypted. So if an attacker owns the whole machine, then they possibly could get all the credentials out. And the third option is you've got hashing. Now, the thing about hashing is there's lots of different ways we can do it, but all of them have this same concept where a hash is a one-way deterministic algorithm. So if we store a password and we hash it, you can't unhash it. There's not a private key. There's not a process to get the credentials back out. The way you log on is you apply the same process, you get the same result, and you compare them. And if they match up, then the two ciphers match up, you log in. So that's good. That's the start of it. Now, the problem if we just hash is that every time we hash, let's say the word password, and we use the same hashing algorithm, we get the same cipher. So, for example, a website gets breached and all they've done is hash, and there's all these hashes that get out there in the wild. You plug one into Google and Google comes back and says, yeah, here's the plain text version, because it's always the same result and they've all been released out into the wild and indexed. And short of having very obscure passwords, which is only a very, very small percentage of people, everything's out there. So the idea was we came up with Salt. And Salt is random bytes. You add random bytes to the password. You store the Salt in the database so that you can reproduce the process later on. And now you have randomness. So the theory then being that, okay, that gives us some protection because we don't have this problem of everybody having the same cipher for the same input. Yeah. So that helps. Now the problem is, and this is actually the way ASP.NET has done it in the past as well. It's a little bit different now. The problem is, although you can't undo the process, you can repeat the process. So for example, if I have a dictionary of 20 million words, I can enumerate through that dictionary, pick a Salt out of the database, add it to the password, hash it, and then compare it. And that sounds like a laborious process, but using consumer level graphics cards now, because a lot of this hashing by attackers is done in the GPU, you can get up to about 7 billion hashes a second. And this is from a few $100 on a graphics card. So the problem is, because hashes are so fast, attackers can sort of enumerate through this process and crack things very, very quickly. So what we try to do is slow it down. And this is really the variance there that a lot of developers don't get. It's one thing to have a hashing algorithm with Salt. It's another to make sure that it's not so fast that an attacker can just go through a dictionary and crack things very quickly. So, for example, if you create an ASP.NET MVC4 web application, the default template and the membership provider used for that will have 1,000 iterations of a SHA-1 hash using Salt. So it's basically going to take an attacker 1,000 times longer to achieve the same result as what they did with, say, Visual Studio 2010 template, where it was all just a single round of SHA. There are other people that say it should be 5,000 rounds or 10,000 rounds, but that's a really, really critical difference.
Okay, is that just, I mean, I might be simplifying this, but is that just kind of delaying the inevitable? I mean, for a while, it was, a single iteration was fast enough to really care about it too much, but you're saying now that consumer level graphics cards can do, what was it, 7 billion or something in a second?
Yeah,
so if we just
billion with a B.
With a B, right. So that's a lot, but I mean, is it just the case that, in a couple of years it'll be 700 billion? So are we just kind of delaying that a little bit?
I think it probably depends on how much faith you put in Moore's law. In a couple of years, it might be 14 billion.
Okay.
Yes, I think maybe the right phrase is, rather than necessarily delaying it, it's increasing the level of difficulty. Because if 7 billion a second is too slow, you just get 2 graphics cards, right? So now you've spent, $600, $800, and now you've doubled it. And this is what people do. And there's, security researchers out there who have arrays of graphics cards that have got 20 of these guys in there, and they're doing, what's that, like 1.4 trillion or so, 140 billion hashes in a second. So the question is, what's the right level to set the bar? One iteration of a hash is useless. 1,000 iterations is, it's a lot better. It's probably not too bad by today's standards. Where do you set that limit? And I think the answer to that depends on a few factors. So one factor is, when you do increase the workload of a hash, you're increasing the workload of the CPU. So, what is your infrastructure like? Are you going to be able to have a large-scale system where it's going to take 1,000 times longer for a fairly common process? The other thing is, what's the value of the asset? So if this is a little blogging site that really doesn't have much value on it, who is going to want to spend the money or the time to get through that, assuming that it's not a very sort of low-hanging fruit? But at the end of the day, if it's a government who decides they want it, you're toast anyway. They've got the resources. So it's really going to depend on the nature of the site. And, of course, how much money you want to throw at it as well.
Okay. So you mentioned that out of the box, it's 1,000 iterations of a SHA-1 hash, is that right?
Yes, so for an ASP.NET MVC4 web application created in Visual Studio 2010, the new membership provider in there does make it 1,000 iterations.
Wow, that's more impressive than I thought it was, actually. I thought it was a fairly standard SHA-1 hash with a salt, but the iterations definitely makes a difference.
Well, the interesting thing is, if it's a web forms application, even though it might be an ASP.NET Web Forms 4.5 application, we're pretty much back where it was before. I think it's only one or the equivalent of 2 iterations. But anyway, it's a very low number of iterations. So it's a bit of a problem, but I do know that there's a bunch of stuff happening in this sort of membership provider space. And I think that as we progress now, we'll start to see more options available, not just to increase the number of iterations of a SHA hash, but make it a little bit easier if we want to use another hashing algorithm like bcrypt or something like that.
Yeah. Okay. Great. Okay. Well, that's some good stuff to know. The other topic you mentioned was HTTPS. Can you drill into that a bit more?
Yeah, this one's interesting. So, obviously HTTPS, most people will associate to encrypting data in transit, which is true. And most people think of it insofar as, I need to protect sensitive data in transmission. And when I talk about HTTPS, I like to try and talk about 3 different things. And the first thing is, it gives you assurance of identity. So when I go to, say, anz.com.au, I can go and look at the certificate. I can see that it was issued to ANZ, particularly the extended validation certificates, where you actually see the entire name up in the address bar. It's normally in a little green bar. There's a whole bunch of due diligence that you've got to go through to establish your identity. So that gives me confidence that I'm talking to ANZ and not to somebody else. The other thing that HTTPS gives you confidence in is integrity. And by integrity, I mean the content hasn't been manipulated. So when I load a page over HTTPS, I know that I'm getting exactly what the server served up to me. And then the third thing is, obviously, we get confidentiality. So we get that encryption, we get confidence that nobody's been able to eavesdrop on the content. Now, most people just think about the third option, and I'll give you an example of where that goes really wrong. And I'm going to publish a blog post, in fact, just today about this. I've got a little video that shows what often happens is developers will make a login form available over HTTP. And in fact, the example I'm going to use is Woolworths, but there's many, many others that do the same sort of thing. So you go to woolworths.com.au and you go to the online shopping section. It loads over HTTP and you see a login form. When you submit, so you put your credentials in and submit, it posts it to HTTPS, so your credentials are protected. The problem is that you don't get that second attribute of HTTPS, which is the integrity. So you don't know that the login form hasn't been manipulated. So in my video, what I've done is when I load that Woolworths login form, I've already injected a keylogger into it. So as I type each key, that username and that password is being sent off to my site, and it's actually logging that information. So if you're in a situation where an attacker can get between you and the site that you're communicating to, so if they can access anything from your network interface card to your network cable to the router to the proxy to the ISP, any of these points along the way, basically all the points that we have HTTPS to begin with for, if an attacker can get in there, they can siphon off your credentials before you even post them anyway. Right. So that's one thing that I often see done really, really wrong. And in fact, I'll see often people will raise this. They'll say, hey, mate, you're not protecting your login form. I can see it's, or you're not protecting your credentials. I can see it over HTTP. And the site owner will come back and go, yeah, but I'm submitting it to HTTPS, so everything's safe. But it's not. Right. And in fact, there are precedents. There was a precedent a couple of years ago. Tunisian government was harvesting Facebook credentials that way. So when they had a whole bunch of political unrest, the government owned all the ISPs, and they said, hey, guys, when someone loads facebook.com over HTTP, we want you to put this little script in there which will send the credentials off in parallel to our servers whilst they authenticate to Facebook. So there's precedence of it being exploited.
So I guess that's something I don't normally think of. You think of the parts of your website that need to be secured being behind SSL, but not so much the login page itself.
Yeah, well, that's one example. And I mean, the other thing as well, in terms of what do we need to consider outside just the data that we might consider sensitive, is cookies. So, for example, when we authenticate to a website, and it really doesn't matter whether it's ASP.NET or not, normally we authenticate and the website responds and it will set an authentication cookie. And that authentication cookie is going to be the means of identifying yourself on each subsequent request. So, for example, in ASP.NET Web Forms, you'll see a cookie called .aspxauth, and every subsequent request you make to the site will pass that cookie to the server, and that's how the server says, okay, I know who you are, you're Troy or Damien or whoever. Now, the thing is that if an attacker can get their hands on that cookie, then they can go and hijack your session. So they can basically create a new session, whack in a new cookie with that value, and then they are you. So it's very much like the victim has just walked away from their PC, the attacker has come and sat down in front of it, and now they've got full control over everything. So that's got to go over SSL. And another thing that a lot of people don't realize is that cookies themselves, independently of ASP.NET, have an attribute called secure. And when the secure attribute is set, the cookie can only be sent over an HTTPS connection. And you can enforce that in ASP.NET on the forms element in the web.config. You can set a value called require SSL to true. And when you do that, even if you inadvertently make an HTTP request to the same domain later on, that cookie won't be sent, so the cookie gets protected. But of course, you can only set that if you do actually have an HTTPS connection to test with. So then you've got to have a self-signed cert locally. You've got to do the whole thing over HTTPS, otherwise the cookie never gets sent back to the server when you try and make a request.
Okay. So this is, with the SSL stuff, just on that, what about if you don't have a lot of control over your server environment? I mean, if you're hosting your site on your own server with IIS running, that's fine. You can set all this stuff up. What if you're running on Azure or something like that? You don't have so much access to the server infrastructure.
Yeah, well, look, I mean, HTTPS is pretty sort of bread and butter for most hosts these days. And to be honest, if you're going to be handling credentials or if you're going to be handling anything of a sensitive nature that you don't want people to be able to have pretty unbridled access to, you've got to get yourself in an environment that does have HTTPS support. At the moment, I use App Harbor for a few of my things, and setting up SSL is extremely easy. You can go and get a free SSL certificate from Start SSL, so there's no cost involved. If you really want to spend money, it's tens of dollars per year. It's a very small amount.
Yeah. Okay. So it's not really. It shouldn't really be a barrier. We shouldn't be saying, I don't want to put SSL on because there's a cost.
Certainly not for the majority of sites. So where it gets a little bit interesting is when you do start to get either to scale or you've got a lot of external dependencies. So one of the things about an HTTPS page is that you can only put HTTPS content on an HTTPS page. So if I serve you a page over HTTPS and then I call jQuery and I put jQuery on the page over HTTP, then bells and whistles and things start going off on browsers, because what the browser is saying is that it cannot guarantee the integrity of that page. So even though you've loaded the HTML itself securely, you've just whacked in some JavaScript, and you have no confidence in the integrity of the JavaScript. So think about, as developers, we can sort of think about the options here. If you could control the JavaScript on the page, what could you do? I could change the form action path. I could change link paths. If I could control the CSS, I could start to turn stuff off. I could put my own images in there. So, you've got to have that, you basically got to have the whole pipeline over HTTPS. Most of the time that's not a problem, but then when you start to have dependencies on partners, and one of the examples that comes up a lot is ad networks. So does the ad network support HTTPS? And a lot of them do. And then when you start to get to scale, then there are questions about, okay, well, I've now got multiple web servers that I've got to serve certificates from, and there's normally an appliance in front of that, like a load balancing appliance, and that's got to serve the certificates. I might have dependencies on CDNs that have got to play nice as well. So I appreciate as you start to get to scale, it gets harder. And in fact, this is one of the things Stack Overflow is going through. So Stack Overflow, once you authenticate using a third-party authentication provider, everything on the website is actually served over HTTP. So Stack Overflow is very vulnerable to, say, to session hijacking. And in fact, that's one thing I showed at a conference recently. It's very, very easy once you're connected to hijack someone's Stack Overflow cookies. And they wrote a post only a few weeks ago about what's involved in a top 200 website moving to HTTPS only. And it looks like they're going to do it, but it's not a simple thing. But for those of us just starting out with basic sites, small-scale sites, it's a piece of cake, and there's really not a very good reason why you couldn't at the moment, not for most cases.
Okay. Just on that, so the guys, like us who are sometimes working on smaller applications, 3 or 4 people doing a internal kind of timesheet app, maybe it's exposed over the web because people are on the road. How much importance should we place on locking these things down? If there's only a couple of people accessing it, there's not really any sensitive data. Is it worth the risk? Is it worth the effort to mitigate that risk?
Well, that's the interesting question, because that comes back to, well, what's the effort, right? And the reality of it is to stand up a website and do a fairly good job of HTTPS, and let's say it's a timesheet app where really you probably want the whole thing to be secure. What have you got to do? In fact, a timesheet app is a really good example because you've got a fairly captive audience. So, for example, you could just disable, basically just not bind any host headers to HTTP. So forget about port 80, just bind everything to 443. Get a free certificate from Start SSL. If you really want to be paranoid, then go through your web app, and even though the app may not actually serve any content over HTTP, you could go through and make sure that, as I mentioned before, Require SSL is turned on your forms, also turned on your cookies, and that's about it. It's like you're done. So that is a really, really low overhead. So it's a reasonable question to say, well, how valuable is my data, or does it really need to be protected in this way? But when the ease of implementing HTTPS and doing it right is just so easy, I don't really see a good reason not to.
Okay. What about the other aspects of security, things like your forms, your credential storage and so on? Sometimes with existing applications, that's a lot harder. With a file new project, that's great. You have a choice right from the start. What about down the track when you've got an application running already? Obviously, the effort is going to be a lot higher to replace all your passwords, for example.
Depends what it is. So if you've been very bad and you don't have any cryptographic protection on your passwords, it's actually easy because you have everything in plain text and you can go through and you can hash everything exactly the way you want. Likewise, if you've only been encrypting, you can decrypt and you can apply that process. It's much harder if they're hashed because you can't unhash. So the only way you're going to be able to basically rehash is you're going to need someone to give you a plain text version. Either that, or you've got to go through and sort of enumerate hashes over your existing passwords, which starts to get really, really messy. So what I have seen in the past, and in fact someone showed me something similar just the other day, where basically the records they stored for each user had what the hashing algorithm they were using was, obviously what the salt is, the number of iterations of the hash, and then the ciphertext of the hash itself. So basically what they've done is implemented a mechanism whereby every single individual user could have a different number of iterations using a different hash and obviously using a different salt, which is what we do. And using a mechanism like that, at least you can implement a system whereby you can start to raise the bar. So, okay, the next time you log in, we're going to up the ante, you know, we're going to double the number of iterations, or we're going to change the hashing algorithms. Nothing out of the box is going to do that. For ASP.NET, you're going to have to code that. That is going to be a little bit of hard work. But if the protection of those credentials was important enough, then that's something that you could do.
Okay. Speaking of out-of-the-box things, one of the favourite comments that I've heard from you, and I think you dwelled on this a little bit at one of the DDD Sydney events, was the using tools like Elma and things like that. And I know we've spoken about this previously. Are you able to just revisit that? I found that really enlightening then, and scary, I suppose. But yeah.
Well, you know, first of all, I do love Elma. I think it is a really, it's a really cool. So error logging modules and handlers. It's a great tool for capturing unhandled exceptions and storing them somewhere whilst you serve up in the same sort of friendly custom errors page to the user. And then being able to go back and review it later on. I know for myself, you know, a lot of my software, you're not necessarily going to handle every exception. So it's great to be able to go back and see what's been going on. So that's really good, and it's really easy to expose those errors, and it's really easy to expose those errors with no authentication. So it's very easy to make them public. Now you've got to sort of then say, okay, well, what's the risk of that? What could be in my Elma logs? And probably the most obvious one is, you know, we're just talking about authentication cookies. So Elma does capture and record the cookies that were sent with the request. So if I can find an exposed Elma log that's got a valid authentication cookie on it, I can then go and hijack that person's session. And in fact, just before we started recording this video, I've just recorded another one that does exactly that on a fairly major international site. And as soon as they fix it and there's no longer a risk, I'll publish that so you can see what that looks like. And I won't say who it is just in case I change my mind, but I will probably have that up soon. So, you know, that's one thing. But the other thing is that often what you'll find in Elma logs is you'll find things like connection strings. And in fact, what's really scary is the number of connection strings where the user ID is SA. And, you know, why you would ever want to sort of give that amount of privilege to a database account, I don't know. I mean, I'm sure it was very convenient at the time, but it's not good. Yeah. You'll find things like that. I've seen lots that have got user credentials because for some reason the developers decided, well, we want to log the user username and password when the exception occurs. So you'll find all that sort of thing. And the really scary thing about it as well is that it's very easy to discover this on Google. So if you structure your Google Docs search just right, you just find thousands and thousands and thousands of websites that have got exposed Elma logs.
Right. That's a little bit scary, especially if you find your own site on there, I guess.
Yeah, so that hasn't happened to me yet, but you know, I've certainly found a lot of other people's sites, and as you'll see if I make this post, sometimes it's pretty big ones. And you know, there was another incident, I won't name who it was, but a UK bank. You know, it was a bank that had this exposed, and fortunately they fixed that very quickly when it was pointed out to them. But it does happen, and it's a bit unfortunate as well because up until about the time I made this post, which must have been about early last year, maybe 18 months ago, the guidance that was given on the Elma website about how to secure it wasn't really comprehensive enough. So they were securing the Elma handler when it was requested in the root, but the way handlers work in ASP.NET, if you requested that handler from another path, it wasn't secured. So in fact, /elma.axd, great, secured, /foo/elma.axd, not secured. Which was really unfortunate. And that guidance has since been revised, but there are a lot of websites out there that were following that old pattern and not properly securing it in any path.
Right. Okay. So so there's a fair bit that we covered there, I guess, different things to look at. If if as a viewer I'm now, borderline crawling into a ball into the corner of my room crying. If I know I need to do more, where can I go? How do I learn more about this kind of stuff?
Well, first of all, you've got good company because I think a lot of people come to that conclusion. So look, a number of different resources. I think one of the best ones that I've just finished is they have done a Pluralsight course on the OWASP Top 10 for .NET developers. So there's just over 8 hours worth of training video there, specifically for ASP.NET Web Forms and MVC. So that's a good resource. Obviously, my blog, troyhunt.com. You mentioned Hack Yourself First. If you search for Hack Yourself First on my blog, you'll find the one I just did with about 16 different discrete risks that you can find via the browser. And basically everything else on my blog is almost always somehow related to security. There's also a free ebook on there about that OWASP Top 10. There's a few hundred pages of sort of risks and things you can find and how to protect them in ASP.NET. And that is probably a pretty good place to start.
Okay, great. Well, hopefully a lot more people will start getting into this and securing the app, so we see a few fewer scary tweets from yourself. It always worries me when I see you mentioning a few different sites. But hopefully some people will pick some stuff up and have a look at your website and at the post, the Hack Yourself First, and also the Pluralsight course. So thank you, Troy, for joining us, and I'll speak to you again soon.